High-performance computing. HPC is a technology based on massive computing capabilities to help simulating and solving complex industrial and scientific problems. Typically, HPC technology uses simulation to design numerically devices or understand phenomena. It is used in most of the industry and science, for instance, climate modeling, airplane, automobile design, tsunami simulation, bioinformatics, power plants, astronomy, etc. So it's actually everywhere now. A typical HPC ecosystem looks like that. You have some sensor data that are provided by some device. For instance, if you look at seismic, you have some people that goes on the ground and that collect data about with some kind of ecography. And these data are used to build some models that we'll use to do the simulation, and that will be analyzed by scientists and so refined according to their discovery. At the core of this HPC is a big machine, a very big machine usually, with a lot of processors, and typically this machine can be, for the biggest one, can be in a room, take a room that is the size of a football field. You can consider two kinds of problems. The first one is a capability problem. That is, you want to solve a task by a given deadline. And in that case, you want to reduce the time of the task. Typically, if you want to solve a linear equation system, which happens a lot in the scientific applications, you want that task to be done by a time that is reasonable compared to what you're trying to achieve. For instance, you can't wait a year before you get your result. The other kind of problem you have is capacity. In that case, you have a lot of tasks, a lot of simulation, or a lot of different things you want to do. And that problem is actually much, it's easier to solve, because in that case you just add more resources and you will get more tasks done in parallel. But the task by itself are executed in a time that is okay with your deadline. Typically, capacity computing is a problem you find with big data technology, where you compute thousands of search in a database. You want that to be done in seconds, but a search by itself is small. Sometimes you may have capacity and capability problem, and in that case, you will need a lot of resources. HPC application. Most of them are still written in Fortran. That's a very old language. But the new ones are coming mostly in C++. HPC is based on exploiting massively parallel computers, and the parallelism in these machines are between the processor, inside the processors, and inside the processor, inside the instruction set. So HPC has been one of the fields where parallel computing, parallel programming has been used for years, and especially to solve the capability issue. The idea behind that is, because you want a task to be done for a certain deadline, you actually decompose this task in subtasks that can be executed in parallel. And if you look at the other field, not HPC, but mobiles, a workstation, because the number of cores has been increasing, they are facing the same kind of problems that HPC has been facing. So we see more and more commonalities between HPC and other industry fields, such as mobile. So, for instance, if you want to do some image processing in real time on a phone, you will use parallel programming in a similar way as in HPC. The current challenge for HPC is the Exascale Challenge. Exascale is the idea of getting a computer capable of delivering 10 to the power 18 computation per second. And it would be nice to have that by 2020. The idea is every 10 years you provide a factor 1,000 in computing power every 10 years. To achieve that, the energy consumption is extremely important. So right now, we cannot do a computer of this power with this computing budget. It would be at least 10 times this budget. And 20 megawatts, it's already a huge amount of energy. Because you will have a lot of processors, many processors, you will have some that will fail. So the fault tolerance issues is actually extremely severe, and it's one of the challenge in here. So how to program codes where the task or the parallel activities can fail from frequently, basically. And finally, one of the challenge is how to extract from application billion ways of parallelism, so to keep the machine busy at the scale it will be designed. So here are a few questions. What are currently the most powerful computers? Look at in the top 500 list. We'll give you the answer. A new matrix has been introduced, a new ranking, Green 500. What is the matrix used for this one? How do you compare supercomputers with a data center? Okay, so for instance, one of the Amazon data centers compared to an Oak Ridge supercomputer. And what are the commonalities between HPC and mobile computing? A few pointers to look at for the questions. And see you in the classroom.